So guys, as you can see, we have two circuits here. There we have a PNP transistor and there we have an NPN transistor, and these both are BJTs. Now take a look here. We have a bulb which is rated to be operated at 24 volt, while our microcontroller can only provide 3.3 volt. Now we cannot trigger a 24 volt load with a 3.3 volt and 25 milliampere current, because the microcontroller cannot provide more than that. So let's see what happens. So this is a NPN BJT. Now I open the circuit, so the 24 volt bulb is now you can say it's no longer working. Now once I close the switch, see, it starts to work, and the voltage is 16.719 volt coming to the bulb. Why? Because not because of this source, like the source is giving 24, but there we have 16.719. So this is because we are changing the duty cycle given to the base pin of the transistor. So to the base pin of the transistor, 0 to 3.3 volt means the opening current will be like 0 to 24 volt from collector to emitter of an NPN transistor. So if we give 0 to 3.3 volt, like half of, like we give 2 volt over here, then correspondingly it will be like 0 to 24 volt, whatever the value over here. So to simulate that, I'm just changing the duty cycle by changing the resistance. So this means that, see, if the voltage changes at the base pin, maybe through the duty cycle, see, the voltage over at the bulb also changes. At the maximum, we have the maximum, at maximum resistance we get the maximum voltage, and it starts to drop, the voltage at the pin also drops. So this is how this works as an amplifier and also as a switch, like this. So it's only 3.3 volt over here and 24 volt there. Once I close it, then the voltage is given to the bulb. So in this way, if it was a motor, you can control the speed as well by changing this voltage using this PWM. And if it was just a heavy load, just you can use it as a relay by just triggering it using a 0 to 3.3 volt input pin of a microcontroller. Now for the PNP transistor, PNP BJT, PNP is just an inversion of NPN. In case of an NPN, the triggering takes place when we give a positive, like we give a 1 from the microcontroller, then the load is triggered on, else it's off. In case of a PNP, it's inverted. So now here this is a minus. So whenever the minus, like a 0 we send from the microcontroller to the base pin of a PNP transistor, then the load is connected to the emitter pin of the PNP and collector pin is sent to the ground, will turn on like this. So in case of an NPN transistor, the load is connected to the collector pin. See, it is connected to the collector pin, while this arrowhead, the emitter pin, is the ground. While in case of a PNP, our load is connected to the emitter pin, while the collector is the ground. See, and this is just an inversion. Hello guys, welcome to learning microcontrollers. In this video, I will show you what is a BJT transistor. I will explain this to you using a circuit simulation on Multisim Live. So let's get started. So guys, first we go to our just browser. I open the Google Chrome, and on the Chrome just go to the browser and write down here BJT transistor. This window pops up, and we all know this definition of a transistor. We are all familiar with this, that a BJT stands for bipolar junction transistor. Is a 3-terminal semiconductor device used for amplification and switching electronic signals and power. Now see the thing, amplify and switch. We all know that transistors do for both as an amplifier or as a switch, but do we know how it works and what it have to do with our microcontrollers or relays or any other circuitry? How it works, we don't know it. I'm dead sure that half of us don't even know, but we do know this definition. So let me make things clear here. What we mean by amplification, what we mean by switching. So let's get to our simulator. Write down Multisim Live here. Okay, this window pops up, click on it. I have a lecture on this, Introduction to Multisim Live. If you have any problem, please go through that. Okay, click on here and select the account, click login, wait. Okay, we got logged in, click on create circuit. Here you go. Okay, now I zoom in. On the left side, first we make a circuit. For your understanding, I take a lamp, an indicator, and I take a lamp. I place it on the screen wherever it is preferred. I double click on the lamp to give it an initial value. So it is of 24 volt, 20 watt, and burn voltage I make like 30 volt. Okay, that's good. Okay, now this is a lamp here. Now to switch this lamp, what we need? To switch this lamp on, we need a supply of 24 volt, else it will not work. Now we go to the left. Here in the supplies, we bring a DC voltage source and we place it here. I double click to set the values. I make it 24 volt. Also change the symbol because this one is easy to understand. Okay. Now if I connect this supply with this bulb, I know this will turn on. That is what usually happens. So on the simulator we may not need a resistance, but inside this there is a resistance already. So also the ground, this is for the simulation only. You need a ground only for the simulation purpose, like this. I run the simulation. Now see, the bulb has turned on. So this is fine. Now the problem is that we usually require microcontrollers. I go to the Google and I show you microcontroller output voltage. How much voltage a microcontroller can output? So a usual microcontroller is always between 3.3 or 5 volt. PIC16FA777A can give a 5 volt of output signal from any pin. Similarly, our new microcontroller like Cortex series, STM32s, they all work at 3.3 volt. Now this is the problem. If our microcontroller can only output 3.3 or 5 volt, and what is the current? And current. Now that is another question. So the output voltage okay, we go to PIC16FA777A pin max output current. Okay, it is like 25 milliampere with the pull up. Usually it's just microampere. Now it's at 25 milliampere. And the other problem is that maximum PIC16FA777A is 5 volt, and other microcontrollers are usually like 3.3 volt and few microampere, and with pull up it can go up to like 30 to 40 milliampere. Now this bulb requires 24 volt to work. So if we don't have the supply here, and like this we don't have a supply here, suppose we don't have a supply here, we have a microcontroller, and microcontroller pin can give, okay, we call this a microcontroller pin, MCU pin. Okay, this pin can only give either a 5 volt or a 3.3 volt. I make it 3.3 volt the input voltage. Okay, most of the microcontroller nowadays operate at 3.3 volt. So with the 3.3 volt and 20 milliampere, if I connect this here and this here, while our requirement is 5 volt, then what will happen? Either the bulb will not glow or it will glow too lightly to be considered. Now see, the bulb will not glow. Now what is the problem here? We need to control the switching, but it requires 24 volt to glow. Now what we do is that we use a transistor. That is the job of a transistor. Like we have a small load, like we just give transistors base pin a small load like a tap, and it triggers a bigger load using that. That is how transistor works as a switch or as an amplifier. Now what we do is that, okay, we keep this, we just bring it down. This is our MCU pin here, and this is our load here. And now we bring in a transistor. I go to the left, I bring an NPN BJT. Now these are the BJTs. These are the FETs or MOSFETs. I will make a video on these as well, how do they work. So if we take a BJT and NPN BJT, I place it here like this. Now this is a BJT. Now this over here is the base pin. This is the collector, and this arrowhead side is the emitter. Now base is like a gate. Whatever voltage you give to the base, it decides to just to allow the current to pass through the emitter, collector to the emitter. Emitter is the ground, collector is the collecting pin. Now let's do the same. Now we have a microcontroller pin. We want to trigger this load. We bring another power supply. Okay, just copy paste this one. We copy this. Sorry for this. I paste it here. Now I make it 24 volt supply, and I call it bulb power. That's a separate power. Bulb power. Now that is a bulb power, and this is the microcontroller pin here. Now I connect the microcontroller pin to the base pin of the transistor using a resistor. Resistor is just for the safety. In the simulation not required, but I will still use it. So that is how we connect our MCU pin to the NPN transistor base pin. Now I also add a switch as well, so we can control the switching. So I add a switch here in between, okay, like this. Now the other end of the negative goes to the ground, and the emitter, other end of the microcontroller, like microcontroller, will be grounded to the common ground. That is the common ground here. We connect it like this, and also the emitter pin of your transistor also goes to ground like this. So like this, these both have been grounded. Now the collector pin, you connect the collector pin to the power but through the load. Now this is the load. I connected to the one end of the load. From the other end of the load, I connected to the transistor's collector pin like this. Now this goes to the common ground of the circuit. Just this is our common ground of the circuit. Just connect it here like this. Now guys, this is a circuit. I run the simulation. Now see, we are still using 3.3 volt. Okay, this 0 is causing trouble. I want to show you that it is 3.3. So I just pull it down. Okay, now that's perfect. Okay, we are having 3.3 volt power source of the microcontroller. Like our microcontroller can only give 3.3 volt. And now we also have a resistor. So it is further load. Now the load is 24 volt, but it is connected to the load. But the ground of the load is not connected to the ground, so the bulb is not on right now. Okay, I also bring in a power source, a voltage measuring source. So this is our DMM, you can say, and I connect here. So right now, circuit is on. We see this is just microvolt of voltage or leakage voltage or something which is passing. So there is no voltage passing because the transistor is open right now. To close the transistor is just like a switch here. If we close the transistor, then this voltage will pass to the one end of the bulb, and from the other end it will go to the ground, and this will complete the circuit, causing the bulb to glow. But right now it's not glowing. Now I close this switch. See, the bulb has started to glow. We got some voltage over here, 6.8665. Now see, the bulb have started to glow. I open it, bulb is no longer glowing. I close it, bulb is glowing. Okay, see, we got the voltage there, but voltage is very less. Now what I do, I go to this resistor, I change its value to some other value, like I make it 350 ohm, and I close the switch. Now see, the voltage has gone up. So this value of resistor decides that what is the voltage will be. So it is 350, I make it something like 220. This 220 is available in the market like this something. Okay, this is perfect. Okay, now with the 220 volt, now we have a 220 ohm resistor. Now this base value of the resistor, you have a formula for this in the book. What should be the base value? It depends upon the transistor selected, and you select the transistor according to the load rating. Like you have a load which requires 100 ampere of current, then you will select a transistor accordingly. Principle is the same. 3.3 volt of a microcontroller pin will be able to control a huge motor of like 100 ampere, 10,000 ampere value with just a single pulse. That is the beauty of a transistor, using it as an amplifier or a switch. Now see, when I open the switch, we get nothing. When I close the switch, we get 24 volt. So see, now what is happening here? We still have the same pin, 3.3 volt. We are controlling the same circuit using a transistor as a switch. See, it is working. Now do the next thing. Now suppose I want to control the brightness as well. I want this to be controllable. I don't want this to be just 24. Suppose this is a motor. Then in case of a motor, to control the speed of a motor, this voltage need to vary. The lower the voltage, the speed will be lower. Higher the voltage, speed will be higher. Now to do that, we, instead of giving MCU pin, we select MCU PWM pin. So a microcontroller's PWM pin will give you an output in the form that it will be controllable voltage. Like it will be from 0 to, it will not be 3.3 volt. It will be then 0 to 3.3 volt. Now to make it 0 to 3.3 volt and adjustable input, we use a potentiometer instead of this resistor. Now delete this, go there. In the resistors, you have this called potentiometer. This is a variable resistor. We place it here like this, and I connect one end to the positive like this, and the other end, this end, the adjustable pin will go to your transistor, and the other end, that is this pin, will go to the ground of the circuit like this. Now we have replaced it with a resistor. Now to the right, change the input, the fixed volt value. I make it to 20 ohm, whatever you prefer. Okay, I run the simulation now. Now see the voltage there. I change it. See, once I change the resistor value, the input voltage automatically changes. I bring it here, you can see the voltage. See, I change the resistor value, the voltage start to increase, 10, 12, and the bulb start to glow until it reaches a 24 volt. Now again, remember, you have to be very good with selecting the resistors. This depends upon the formulas. Now again, I change the resistor to 10K. Usually we use 10K for the adjustable. Okay, 10K. Now I run the simulation. Okay, there we go. I click here on the change resistance. Okay, now I like move the knob of the resistor. Then if I move the knob of the resistor, I go down, the voltage starts to decrease. Then I increase the resistor knob, the voltage is increasing, and it goes to the maximum. See, now this is the beauty of a transistor. Like with a transistor, now you are giving this basically through a PWM pin. You just change the duty cycle of the PWM, and the speed of a motor or this voltage changes, causing the speed of the motor or the brightness of an LED to change. Now this is called using transistor as an amplifier. So this simulator is bit giving different values, but on hardware you will get exactly same. The higher the PWM, now 0 to 3.3 volt causes here 0 to 24 volt change in the voltage. So this is how you use the transistor as an amplifier. Now for this is for the NPN. If we use the PNP is just the inversion of an NPN transistor. Okay, now this is we save this as NPN transistor. Okay, I save it. I click on save. Okay, it's saved. Saving the file. Okay, now if you have a PNP is just the opposite of an NPN. Okay, now it's saved. We just copy this, Control C, and paste it here like this. Now I go to the left. Here I select a PNP. This is the PNP transistor. I place it down there. I rotate this like this, and what I do is that I remove this transistor, but before that I place this here, the NPN transistor. Okay, I mirror it as well to bring it here. Okay, now we have the NPN transistor here, and I delete this one, NPN one, sorry, PNP is here, NPN is gone. Now with the PNP, we remove this and we bring in a fixed resistor, just a resistor of value, some value like 220 ohm. Okay, now let me show you how the PNP works. PNP is just the inversion of an NPN transistor. Now see, the PNP is on when the switch is closed, it's off when the switch is open. Now it is just the opposite. Like in case of an NPN transistor, bulb turns on when the switch is closed, and in case of a PNP transistor, it's opposite. So it will turn on the circuit, whatever the load is, when you have given base pin of the transistor a ground or a 0. Like from the microcontroller, you write 0, it will turn on the circuit. If you write 1, it will turn off the circuit. So that is just a difference. PNP is the inversion. And in case of PNP, your input voltage, the load will be connected to the emitter side and your collector side goes to the ground. While in case of an NPN transistor, emitter goes to the ground and load is connected to the collector side. So that is the difference. PNP is just like an inversion of the NPN. So guys, this is it. That is just I wanted to tell you how it works, how a BJT transistor works as a amplifier or as a switch. So guys, I hope you learned something from this lecture. We'll see you in the next lecture. Goodbye until then.